Just a little question. How many of you are involved with programming for audio? I mean, audio on the desktop, not embedded. One. It's more or less what I expected. So you're all real-time experts, but very few audio people in this group. That's why I wanted to do this very quick presentation. It's only 5 slides. It should take 5 minutes, maximum 10, to introduce you to a system which is used to implement audio applications on a standard language system, not for embedded use. So it's called Jack, which is the recursive acronym, Jack Audio Connection Kit. It's used by all serious audio applications to connect to each other and to the sound card. By serious, I mean things not meant just for entertainment, not M-Player, not Skype, things like music production software, digital audio workstations, software used for acoustic research, synthesizers, that sort of thing. How does it work? It processes audio and also MIDI, but okay, that's not important here, in fixed size blocks. So audio, digital audio is samples, normally 48,000 per second. Jack defines a block size, 256 is a very classical one, and audio is processed in blocks of that size. So what does it look like for the programmer? For the programmer, there is the Jack application, which is normally called the engine, and there is a library called libjack. The two talk to each other via unspecified means. Clients link with libjack, and they define a function which is normally called process, can be called whatever you want, which is a callback function. So libjack will call the process functions within each application when it wants to, and that will run within a scheduling FIFO thread, so a real-time thread, which is created by libjack, not by the application itself. Just to be clear, these are different applications written by different people, independent of each other, so different processes, not just threads. So that's from the programming point of view. From the user point of view, applications have ports. Ports means inputs, outputs for audio. And these ports can be interconnected with each other in any way you want. And also with the sound card. So I said processing is done in blocks. Each block is called a cycle. And for each cycle, Jack will read data from the sound card. So many samples, exactly the same number every time. And then call all of the clients in an order which is determined by their connections, by the dependencies. So in this case, C has no inputs, it can run immediately. A and B depend only on the sound card, so they can run immediately. D has to wait until A and B are ready. B has to wait until B is ready. And when all clients are done, Jack will write any data to the sound cards if necessary. So that's the basic principle, from either the programming point of view or from the user point of view.
Sorry, question. The process is invoked. Invoked periodically.
Yes, the whole thing works with fixed periods.
Yeah, which depends on the number of samples and on the sample rate.
It is the sound card which will provide the start of the period. So here in the sound card or in the driver, you have some buffers. When the buffer is filled to a fixed number of samples, that will generate an interrupt or an event that will trigger the whole thing.
Okay.
Everything runs, data is sent to the sound card, and everything waits until the next cycle starts.
Sorry. And the number of samples per cycle, is it the same for all the clients, or every client can configure?
It's the same for all clients.
Thank you.
There are some clients which internally use larger periods to do certain things, but that's really it's nothing to do with Jack.
Okay.
But it's possible to do that. So entirely cyclic. So what's the current status of this? Has existed for 10 years at least. It was introduced in the Linux Server Conference 2003, if I remember correctly. And I must say, for the last 8 years or so, it has been an extremely reliable and very performant piece of software. It works very well at the moment. Until recently, you needed a real-time patched kernel to get good performance. With recent kernels, if your period size, your block size is not too small, you can just use the standard kernel, it works perfectly. All the machines I use in Parma for music production, I have the standard kernel, not patched, I have no problems at all. That's with a period size of 256 samples, which is 5 milliseconds. So you need the patching only if you use very low block sizes, high cycle frequency, which is done by people who produce live music, for example, to minimize the delay. Problems still exist when you set up a new system for audio processing, but usually have nothing to do with the kernel or with the performance of Jack. Real problems are shared interrupts, for example, on USB sound cards, misbehaving drivers, not only the audio but others, which can take your CPU for a long time and last, and poorly designed hardware. There's nothing we can do about that. So, scheduling. So the order in which the process functions of each client are called depends on the connections only, on the dependencies between those different programs, which one takes input, output from another one, and so on. And these things can change from one cycle to the next. It's completely dynamic. Port connections can be made by the user, by the program, by session manager, management, by whatever. And it's very dynamic. It can really change each time. Normally it doesn't change in each cycle, but it's possible. And if it changes, the system should just go on. There are actually two versions of Jack. Jack 1 is the original one, programmed in C, and it runs clients sequentially, always. Even if you have a multi-CPU machine, there will be only one Jack application running at a time. Jack 2 is a newer version, C++, and it will run clients in parallel on a machine which allows it, and if the dependencies allow it. In the example, for example, here, A, B, and C could be run together in parallel by Jack 2 because they don't depend on each other. But both versions are fully compatible at the API level, so you can compile a program on a system which has Jack 1 installed and run it on a system with Jack 2, it's no problem. Now, what do we have? The exact time at which the client runs within each cycle is completely irrelevant. Because the data is buffered anyway. The client gets, for example, 256 samples input, has to process that, produce 256 samples output. When it does that, doesn't matter as long as it's done within the same cycle. So all work should be finished before the start of the next cycle, of course, which is imposed by the sound card and nothing else. And normally, in most clients, the CPU load per client is more or less constant. But there are applications in which it can change quite drastically. For example, a synthesizer depends on the number of notes you play at the same time, for example. So what can we have within one cycle? So we have just 3 applications, A, B, C. B takes input from A, C takes input from B, so the normal order of execution is A, B, C. Suppose that A in the next cycle has a lot less work to do because I've released all the keys on my keyboard. It will be much shorter. What happens is that B will run twice, but time from here to here is less than 1 gigabytes. It's also possible that for example, these tasks are part of a mixer. I hit the button and I reverse the order of A and B. Perfectly normal thing to do in audio processing. So again, this case, B will run before B will run again earlier than 1 cycle after the last time. So, when I wrote this, I didn't know anything about what I have learned in the past 2 hours. I've learned a lot now, but still the question remains. Does deadline scheduling offer any advantage in this kind of scenario? That's something I would want to discuss with the people who know, and that's the reason behind this presentation, just to create the context to do that. So that's all. Okay, thank you. Thank you.
Are there questions for Fons? Yes, one.
Yeah, just a quick question. You said all the process callbacks run in different threads, one per client.
They are, yes. The threads
Okay.
are created by the library.
So
They are also in different processes most of the time.
yeah, but one thread per client. The clients can be different processes, right?
One application, one process could have many clients.
Okay.
Usually it's one.
Okay. So let's assume you don't have dependencies. Okay, let's assume you have 3 clients in 3 different applications reading from the sound card. At the beginning of the cycle,
no output. And no output.
yeah, and the output on a different sound card, whatever. When a cycle starts, what does Jack do? It let's say wakes up all of the threads for the processes, or decides a schedule for the.
It will wake up all 3. Yes,
All 3
in this case.
Okay.
Yes, they will depends on the if it's Jack 1 or 2.
Okay.
They will wait on I think on the semaphore or on the pipe 1 or 2, and
Okay.
they will wake up all 3 of them. And then if
So it's not trying to implement some kind of a schedule between the clients. It leaves it to the kernel scheduler.
the only scheduling it does is based on the dependencies. nothing
Yeah.
else.
Okay. Okay. Thank you.
Any other question? No. Okay, so we can thank Fons. Okay. Next speaker then.